Welcome. In this video I'm going to show you how you can determine Cohen's age for one sample using Python and the stikpetP library. If you want to watch a video without using my library, I have a link over here, and I'll leave a link to this Jupyter notebook in the description below. The Python version that I'm using is 3.97, and this video will focus on how to actually obtain the value, not so much on the interpretation and whether or not you should be using this. The introduction is of course the same. You can read it in the Jupyter notebook. It shows a little bit how the formula is actually derived, and also that there are some rules of thumb for Cohen's age, but that's for the regular version, not the one sample, but one can be converted to the other. A little bit more on that later. To show you how this works, I'll need an example, so I'm going to be using pandas for that, and then I can use the read CSV file. It's from student statistics, so there was some data on students from a long time ago, and gender was actually back then binary. There were only two options, the male and female. So as we can see, there were quite a lot of males, so probably this was significant. You can use a one sample binomial test or proportion test for that, and we're going to have a look at the effect size for this. The stikpetP library can be installed from my GitHub account, so pip install and then the link to my GitHub. Then I can load it just as any other one once it has been installed once, and I'll use it PS as my initials. Now the function of interest is ES, effect size, Cohen, age, and then one sample. It only has two parameters, data and the codes. Codes is optional, so if your data has more than two categories, you can specify the two that you actually want to use. Put a question mark in front of it and you'll get some more info. Now let's see how this actually works, and in this case Cohen's age was about 0.50. To see if this was a lot or not, you can convert it to a regular Cohen's age using the ESConvert function. So ESConvert, and then from Cohen's age one sample to a regular Cohen age, and then I get about 0.71 rounded. And then you can use the TH for rules of thumb, Cohen's age function, to actually get a rule of thumb from Cohen himself, who would then classify this as a medium effect size. If you're interested in how to do this without libraries or other libraries, see my other video or have a look in the Jupyter notebook. These were the references I've used for this, and I hope this was helpful, and thank you for watching.